Alright, welcome back to this video on the TheCodeBakery. In this video, we are going to be trying to solve this question for the USACO 2020 US Open Bronze Division, Problem 2, which is Social Distancing 2. So, I would highly recommend all of you guys to pause the video right here and try to solve it by yourself. The problem statement is right here, but if you guys want, you guys can try to go to the website yourself and submit your own solution. So hopefully by now you have paused the video to at least read the problem and maybe try to think about how to solve this. But right now I'm going to get into the solution. So the problem is essentially asking, we have n cows on this number line and some of these cows are infected with COVID-19. So these ones would be infected. This is not infected. And the problem that we're trying to solve is the minimum number of cows that initially could have been sick prior to any spread of the disease. So for example, I could say that this one, this one, this one, and that one were all initially sick. However, this would not give us the minimum number, and ideally to get the minimum, what we want to do is we want to have these cows spread the disease among each other. So for example, we would want this one to spread it maybe to this one, and then this one to spread it to this one, and this one to spread it to this one. So we have one cow which spread the disease to all of these cows, and then this one would also have to be initially infected. This isn't the answer though, but this is what we want to have. One cow infecting as many other cows as it can. So another very important piece of information is that Farmer John knows that there is a radius such that if one cow is infected, the other cows are infected in that radius, and then that cow can also spread the disease among another radius. But unfortunately, he doesn't know this. So this problem actually gives us a very important note and piece of information, such that if r is less than 3, the cow position 7 would have infected the cow position 10. But in this case, the cow position 7 is infected, but the cow position 10 is not infected. Therefore, we know that the radius cannot be 3 or larger, or else this cow would have been infected. And this is a very crucial piece of information to solve the problem, because for this problem we are going to try to find the maximum radius possible, and we want to find the maximum radius possible such that this one cow can try to infect as many other cows as possible. And we would do this essentially by looping through the array and seeing the distance between two cows such that one is infected and one is not infected. So for example, I would go through these two cows right here and I'd say, is one infected and one not infected? In this case, no. So then I'll go to the next pair of cows. These two. Again, they're both infected, so I can't conclude anything about the radius. These two, again, both infected. However, now I come to this, and I say, okay, one is infected and one is not infected. Therefore, the maximum radius could possibly be 3. I mean, it has to be at least less than 3. And then I would see these two right here, and I know that the maximum radius is less than 5. But because I already said that it has to be less than 3 over here, then our maximum radius is 3. And this would also fit this one, because this is the maximum radius is less than 5, and 3 is less than 5. Alright. So now that I got the maximum radius, now what I want to find out is the minimum number of cows that could have been infected first. Now, how do I do this? So one thing to note is that we don't necessarily have to find which cows were infected or which cows were infected at the beginning. So I don't necessarily have to say this cow was the infected cow instead of this cow. Instead, I just know that this is a group that all came from one person. This is a group that all came from one cow. And this is a group that all came from one cow. So essentially what I'm finding right now is the groups. So in this case, now I would look through all the cows that were infected. So I could just get rid of this cow right now. And I would essentially loop through the array once more to see that, okay, 1 and 3 are both infected, and the maximum radius is 3. Therefore, both of these cows are in one group. So this is a group, and now I would check these two cows, 3 and 6. The radius would be 3. However, I know that because 7 and 10 were not infected here, that 3 and 6 also could not. 3 couldn't have infected 6 or vice versa. So therefore, this right here will not be a group. Now I would go through 6 and 7. These two. 6 and 7 have a radius that is less than 3. Therefore, this is also a group. Now I'll check 7, and I would skip over 10 because I know that this isn't infected. 10 is not infected. And I'd say the radius between these two is 8. And this is definitely much larger than 3. Therefore, this one has to be a group by itself. So in the end, we get 3 groups. And for each of these groups, they all have one cow that the COVID-19 originated from, which eventually then spread throughout everyone else. Alright, so I'm going to quickly go over my code. So I have 2 arrays here that I'm using. The first array is to show where this integer is for the position of the cow, and this boolean is whether the cow is infected. I also have another array here, and this is the array that contains the positions of the infected cows. So cows that aren't infected will not be part of this array. So over here, I'm just going to take in my data, and I'm going to put in the cow, whether it is infected or not, into my array, and this is the normal array. And also I'm using a pair so that it is a pair of the position and whether it is infected. And over here I have, if the cow is infected, I'll put this into the infected position array. And both of them are having this position where the cow is. Now I want to sort the array, and I sort the array based off where the cow is in the graph or the line. So I'm doing this numerically such that the cows in the lowest position are first and the cows at the highest positions are last. So therefore this way I'm comparing 2 cows that are right next to each other instead of 2 random cows. Now over here I'm just looping through my normal array, and I'm saying, okay, if one of these are infected and the other one is not infected, then I want to take the maximum, then I want to have this maximum distance variable, which is essentially the minimum of what it is and the difference between the infected cow and non-infected cow. And like I mentioned before, this is really important because we can then use the maximum distance variable to find the number of groups that we have. Also, I have to make sure at the end to decrement the maximum distance variable by 1 because I want to make sure that all the cows which are in a group are 1 less than the distance between a cow that is infected and isn't infected. Now over here I'm going to have this, okay, actually first I want to show this. So if index is equal to 0, so that essentially means that if we have in the end like no cows which are infected, and obviously this would just be 0, But now I'm going to have this answer, which is essentially the number of groups, and I'm going to sort my infected position just like how I would sort this array right here, because I want to compare two cows that are right next to each other instead of two random cows. So right here I'm essentially saying if the second cow minus the first cow's position is greater than maximum distance, that means that a new group has formed, because those two cows cannot infect each other. So in the end I get the number of groups, and remember that for the number of groups, this means essentially that each of these groups originated from one cow. And in the end I'll just print out the number of groups, or the number of cows that it originated from for each group. Thank you for watching this video on the Code Bakery.